All right, everybody. Welcome to day 2. So we've got a really fun schedule packed for today. So on the docket for today is circle theorems. So circles are everywhere in life. So we're going to be going over that. This is an e-math topic. So if this is relating to you, you can stay. If you're not taking circle theorem at all, then maybe you can hang around, learn something new. Totally up to you guys, all right? So let's jump right in. Let's get started. I will show you guys a question that we will go over. We won't solve it right now, but I just want to show you guys the question that we'll be going over. Also, I love that you guys are saying hello to everybody else in the call. This makes me quite happy. What a great way to start this call. So on the right side, you have this question. So I just want you to look at this question and think to yourself, can you find all these other angles? Like this one, this one here, this one, maybe this one. How many of these angles do you think you can find? Right? This can be quite overwhelming. There's so many lines in here. Like, who draws a circle right like this, right? Who draws a circle, puts all these lines, and puts in a little, I don't even know what you call this shape thing over here. I mean, who does this, right? So the question is, can you do this? This is sort of what we'll be tackling today. So I'm gonna do a quick poll, like yesterday. How do you feel in your understanding of this question? So here's another poll. How is your understanding of being able to solve all these various angles? Okay, all right, so we've got people sort of all over the place. Someone says, I'm gonna go with meh. I'm sorry, there's no meh on the options. It's a numerical scale. Maybe we'll add that in. Okay, all right, so basically that's the topic for today. By the end of this call, actually, I think you guys will be pros at being able to solve this problem, all right? So to get started, this is what I've done actually is if you go on the website now, if you click on this notes page up here, right? If you click on notes again, then it will take you to a new page. It will take you to this link. And on this link, there are both circle geometry over here and further differentiation from yesterday. Those of you that wanted videos from yesterday's class and today's class, the videos will be actually posted on my YouTube page. So if you go down here, click on this YouTube page here on my website, idealfundamentals.com, and subscribe to this page, and you will get an update. I'm posting the videos from yesterday and today on the YouTube page this weekend, actually. So if you subscribe, you'll be able to rewatch those videos, okay? And again, it's idealfundamentals.com. If you look at the URL, it's idealfundamentals.com, okay? So that's what we have. This is the topic that we're going over in. I have a quick poll, first of all. Is this a fun topic? Do you like circles? Is circles and circle theorems enjoyable? Yes or no? Nice, okay, this makes me quite happy. All right, so about 2/3 of you are saying that you like circle theorems. Let me try this one again. Do you absolutely love circle theorem? Is it really, really cool? Are you in love with circle theorem? Okay, all right, one third of you now. Okay, so some of you may be asking, well, why do we have to learn about all the circle theorem business, right? So if you go to the notes page over here, this is what we'll be going over today. The first thing I've put in is why should you care? So let's remove this for now. What you will notice is actually in long ago, when this was done, this guy called Aristarchus, that's his name, used circle theorems to actually figure out the distance to the sun. So it has some pretty cool applications. So if you're interested, basically he figured out that when you have a quarter moon, that means if this is the moon, you only see about half of it. When you have the quarter moon, the moon is actually at an angle like this. This is not a good color. Let's see, at an angle like this, because the moon is then perpendicular to the sun. And the moon is far enough away that this angle is quite significant. So this is what, 3 degrees. And using that angle, he also somehow knew that this angle was 3. And using that, you have all the information to be able to find the distance to the sun, right? Using the rule, you know, this is a 90-degree angle. So this is pretty cool. And yeah, and our Starkus did it without the textbook. I love that comment. Yes, exactly. So it's actually pretty cool. Also, you can use it if you are looking at something. I'm gonna draw an eye, right? And there's a tree here. Then you are seeing the top of the tree and the bottom of the tree. This is D. This is D. Then you can also do stuff with this. Okay, so it's actually pretty cool. But let's say you don't care about this, or sorry, if you do care about this, you can watch this video that we have on the right side on the website. It's pretty interesting. But I want to tell you guys that if you just engage with the content emotionally, you will enjoy it a lot more, and you will be able to remember it a lot more. So, for example, a quick poll: how many of you like Harry Potter? Do you like Harry Potter? Yes or no? Okay, all right. So quite a few of you like Harry Potter, and can you tell me? No, anime. People of you like anime. Okay, all right. I've not watched that. Can you tell me? Can you put in the chat this any spell? Can you put any spell from Harry Potter into chat? Any spell, if you remember any spell. Wow, somebody already put in Wingardium Leviosa. Okay. Put in any other spell. Stupefy is another good spell. Yeah. Abracadabra. I'm not sure if Abracadabra is one of them. Expecto Patronum, Expelliarmus. Wow, you guys are getting the spelling is correct as well. Crucio. Yeah, look at that. Okay, so let me ask you, when are you going to ever use these spells? Right? When are you ever going to use Expelliarmus or Crucio or Expecto Patronum? Right? Never. Yet you're doing such a good job by remembering it. And so the key here is that because you're engaging with that content emotionally, so it makes it so much easier to remember. Okay, so today I ask of you that you engage with this content that we're going to go through emotionally. Okay, so try as hard as you can to fall in love with the content that we're going to go through. Okay, it will make it a lot easier. So, all right, so let's get started. So on the docket, what we have today is these rules here. So there are angle properties and symmetry properties on the left and right. So let's jump right into them, actually, and let's learn them. We have parts of circles that you should already know. A summary of the circle theorems we'll be going over today. But what I want to show you is going all the way to the bottom, you have this widget section. And this widget section is probably my favorite section, which is when you are learning the content, we're going to learn the content very visually. So what's the first theorem? The first theorem is equal chords are equidistant from the center, okay? So if you guys want, I recommend everybody going to the website actually, and going to the notes page at the same time. So if you go to the notes page with me, I encourage everybody to play around with these widgets also. So what this is saying essentially is if you have two chords, so I'm going to draw these two chords on the right here. A second. Okay, so if you have any two chords here, and these chords are equal length, then their distance from the center will be the same. So if this is equal, then this is also equal. The distance from the center is the same. So if you look at this, let's say this distance right here is 2.69 on either side. So we can change this to be 2.69, and you'll see that there's the same distance, the 2.96 from the center. You can do this anywhere. So let's do 2.69 here. Again, same. So it's actually pretty cool. You can just keep changing this around. So let's make this 2.84. Let's see, 2.84, bam, is the same. Do it again over here, 2.84, bam, same distance. It's a really cool, it's a pretty cool theorem, right? So this is the first theorem. So what I recommend everyone is to get your pure notes out again. We talked about pure notes yesterday, which is this one fresh sheet of paper where you'll write down your notes. And on this sheet of paper, you can write down the first theorem, which is equal chords are equidistant from center. So like yesterday, we'll be doing a bunch of questions later on. They won't be in a Kahoot format today. They'll be in a slightly different format. So these rules will be important to know then. Okay, so keep writing these rules down. So this is the first rule. Just to really emphasize on this rule, you can see how if I'm changing the length of the chord, both of these chords are the same length. As you change the length, you can see how their distance from the center remains the same, right? You can put these anywhere. Like, let's say we put them like this. Again, as you change the length, no matter what's happening, if the length of the chords are the same, the distance from the center is the same. A side note is, if this distance is the same, well, each other line here is the radius, right? This line here is the radius. Let's use a different color. Radius, 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 radius. So therefore, these are congruent triangles, basically. So that's just emphasizing this rule, all right? Awesome, all right. Let's do the second rule. So what the second rule is saying is, if you have a chord, any chord, then the perpendicular bisector, so the bisector means it cuts this chord in half. So this length and this length is the same. The perpendicular bisector means, perpendicular means it goes, oops, it goes through the center at a 90 degrees. Yep, so this is 90 degrees over here. The perpendicular bisector will always go through the center. It will always go through the center. And this is so cool. If you're also following along with me, you can change these perpendicular bisectors, sorry, these chords, and you can see how the bisector is always going through the center. Let's show the center. Isn't that nuts, by the way? Right? Like, isn't this so cool? So this app, this is all available to you guys for free. If you just go on the website, click on notes, you can play around with these. So I like to do this visually. Visually is important because it helps you commit this to memory, okay? So just really commit this to memory visually. Don't just memorize this thing. Commit this, understand this visually, and then commit this. All right, so what do we write down here in pure notes? Perpendicular bisector of a chord passes through circle. All right, so make sure you're writing these pure notes down because this will be used in the quiz later on, okay? So let's come down here to the third rule. Okay, I absolutely love this one. So this is saying that tangents, oops, if you have tangents, then these tangent lengths are the same to the point they meet, all right? So check this out. If I take this dot and I move it around, they're staying like a tangent, but the two tangent lengths are the same. No matter how close you get, they're still the same. Isn't that so cool? It's insanely nuts, right? So you can move this around. If you take this inside, then of course it doesn't work. But if you go outside, the tangent lengths are the same. And notice in the tangent means this is a 90-degree angle here. This is also 90 degrees, yeah? So let's write this one down also. So if we have, how do we do this? This tangent here, then tangents from an external point. Wow, what's happening? External point are equal in length, all right? So this is the same, this distance is the same. All right, so we're gonna keep going. Hopefully you guys are writing this down. Let's go to the next one. All right. This one is building on the previous point, which is now what you have is you have these two tangents that are meeting. And over here in the middle, you have a perpendicular bisector. This is a perpendicular bisector. Whoa, what is that? Cool. All right. This is a perpendicular bisector, which means it's bisecting this angle at its halfway point. It's bisecting this angle at its halfway point, and therefore it's also bisecting this angle at the halfway point, all right? That's the rule. So as you move this around, you will see that the angles are being bisected. No matter what happens, these two angles are the same, and these two angles are the same, right? What you may also notice is that you have a right angle triangle here, so that this angle and this angle are 90 minus each other. Okay, this is just an advanced thing you can get, but no matter what happens, it's bisecting. So just really, guys, look at this and try to commit this image to your memory. Don't try to commit the rule to your memory. Try to commit the image to the memory, okay? So let's draw this out. We have this angle, another angle, and a perpendicular bisector. And from this point, we bring down this thing here, this thing here. So this is x, x, y, y, right? These two angles are the same. These two angles are the same. So let's write this down. Line joining external points. Oops. External point to center bisects center angle. Okay, that means if we go from A to O in the center, it will bisect this angle. All right? Good, 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 good. Keep writing this down. Good stuff. All right, let's move on to the next rule, shall we? This one's really cool. I didn't believe that this was actually a thing. So if this is your diameter, A to B is your diameter, then if you draw out a triangle to the circumference, anywhere on the circumference, then that angle will be 90 degrees. And this is crazy. I'm moving this point and I'm like, wow, well, how is this staying 90 degrees? But it is. Okay, so again, commit this image to memory. This is insane, right? Yeah, nice. You guys are saying next level. Absolutely amazing. Agreed. So again, commit this to memory visually. Don't commit it to memory just by rote memorization. Understand this visually. So here we write down angle in a semicircle is a right angle. And what I'm writing down in text, this is just a guidance. You guys can write down anything you want over here, all right? You don't have to copy exactly what I'm saying. Write down whatever makes sense to you after playing with this shape, all right? Good, all right, let's move on to the next one. This one's really cool. It's also actually pretty self-explanatory, but the angle between a tangent, so this is this line up here, and the radius, which is this line down here, is always a right angle, no matter where you go. Okay, it's always a right angle. So it doesn't matter where you are, okay? This one's pretty self-explanatory. So let's draw out a line and a tangent, maybe another line, another tangent, 90 degrees. Guys, you have to say, I am pretty good at drawing freehand tangents, right? Look at this. So angle between tangent and radius is a right angle. All right, quick check-in. Are you guys still following? Are you guys still following along? Are you still with me? We're gonna do a quick poll. Good, all right, okay, good. We've not lost anybody yet. All right, so if you're still with me, then as soon as we get to questions, you guys should be crushing it, right? So let's see, 100% of you guys are with me. This makes me happy. All right, let's keep going. I think we have 4 more rules. All right, so this is where we start getting a little complicated. So what's happening here is, let's do this. If you take 2 points on the circle, on the circumference, so let's take this point. If we take this point here and this point here, all right, then the angle at the center, which means this line is to the center, all right? This is the center. This will be 2 times the angle at the circumference. So this has to be at the circumference, which means anywhere on the outside. It's 2 times. This is, because it's a rounding, it's not showing twice, but this should be 74, I think. Yeah, but I'll show you guys. I'll edit this and I'll show you. So this is the rule, which means this angle between the circumference, so circumference here and the center, this is 2x of this. All right, that's the rule. And so again, if you don't believe me, I didn't believe this. You'd be absolutely right not to believe it. If you keep moving this around, it's the same. Let's make this even so the rounding doesn't happen. 76. So let's make this 80. Good, easy. No matter where you go, it's the same. What you will notice here is what happens if I bring this down here? Will this be 40? Yes or no? Will this be 40 if I bring this down there? Launch poll, yes or no? Wait, why is this? Someone called this a robot butterfly rule. I don't understand why. Okay, all right, maybe that's what it's called. All right, yeah. So some of you guys are mixed. So let's see what happens. I don't know. Let's see what happens. Let's bring this down. Whoa, this is 140. What is happening here? I want you guys to take a minute to think about this. This was fine over here. This was 40 here. 40, 40, 40, 40, 40, 40, 40, 140. What is this? Let's move this around. Let's see. Let's make this 100. Okay. 50, 50, 50, still half. 50, 50, 50, 50, 130. What is happening here? Is this widget broken? I don't know. We'll get back to this. But for now, let's just write this down. Okay, let's just write down what we have so far, which is angle at center, well, is 2x angle at circumference, right? So 2x, x. We're gonna keep this one. This one we don't know what's happening here, right? Let's keep this as a question mark. We don't really know what's happening here. Let's move to the next rule. I think the next rule will help. This one. All right. So this one's pretty cool, which means if you have, again, the same thing is happening. You're picking 2 points on the circumference. 2 points on the circumference. Notice it's on the circumference. Any triangle you draw to the other circumference will be the same. Isn't that crazy? Will be the same. Well, maybe it's not too crazy because this one is basically like 50, 50, 50, right? It's the same here. Therefore, this is the same. So let's just put this down. So let's write this one down because it's a rule. You have to know it in your syllabus. So let's write this down. So 1, 2, 3. So this is 2x, and this is x, 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 right? So angles in the same segment are equal. Now there's this weird word, segment. Do you understand what this means? Do you understand what the word segment means? Quick poll. Are you following along with what segment means? Okay, most of you are, some of you are not. Okay, so let's just go over this quickly. The segment, you see this, if I move this point around, there we go, okay. If I move this around, white is one segment, purple is another segment, all right? So if it's in this segment, it's the same, but if I go into this other segment, it changes. Let's make this 100. It changes, right? We notice this pattern initially. So again, same in this segment up here. So segment means if you have 2 points of the circumference, then one side of this line is one segment, and then the other side of this line is another segment. All right, that's what this means. So that's what segment means. So you can move this point around, and the segments will change. So let's make this 150. So 75 is half. Something else is happening here. Well, let's see what's happening. We still don't know what's happening over here. So let's go to this second last rule. This makes sense. Its angles in opposite segments are supplementary. So this segment here, what does supplementary mean? Let's change this to be, let's see, can I get this to 80? I can't get it to 80. This is really tough. Let's see. Oh, 80.08. All right, we're close enough. Good. Basically, what this is saying is that this segment plus this segment equals 180. All right, that's what they're saying. If they're in the opposite segment, if they're in the same segment, let's see, can I go? They're the same. But if they're the opposite segment, then this angle up here and this angle up here, the sum of them equals to 180. But it's important to note that this only works if the two angles are drawn from the two same points on the circumference, right? So here and here, here and here, from the same 2 points. Good. All right. So let's draw this out. Draw another segment here. All right. So let's draw the segment here. Okay. If we have x, y, and one way to write this is x plus y equals to 180, or in words, angles in opposite segments are complementary. Okay, cool. So here, I prefer this. X plus y is 180. This makes more sense to me. But if complementary makes more sense to you, then that's also fine, right? So if we go back to the rule up here, now this will make more sense to you, except it's not drawn. So there's 130 down here, but there's 50 up here. Okay, so what this means is 50 up here plus 130 down here is 180. All right, that's what's happening. So that helps in understanding. Oh, okay, let's go. Is there one more rule? Oh, that's it. Awesome, awesome, awesome. All right, this is the last rule. I guess we can remove the circle. Good, so quick check-in. Are you with me so far? Are you with me? Okay, cool, so everyone is with me, good. So now we're gonna practice this. So let's get ready. The way we're gonna do this is I'm gonna make chat, or actually, let me ask, are you guys comfortable with making mistakes? Are you comfortable with making mistakes? All right, most of you are. Let me do this again. Are you comfortable with making mistakes publicly? Are you comfortable with making mistakes publicly? All right, not too many. All right, so it's up to you. If you're comfortable with making mistakes publicly, you can put in public chat. If not, you can private chat me the answers to this next segment. But one thing I want you to notice is, let's say we go through all of today and you made no mistakes. Good for you, but also it's pretty much time wasted, right? You could have spent this time learning something else. So what we're gonna do is embrace failure today, right? If you make a mistake, I want you to be happy. Because if you make a mistake, that means we learned something, all right? So we're gonna go through a lot of very, very tiny questions, but a huge volume of them. So the more mistakes you make, the more you'll learn, all right? So it's okay, embrace failure. Don't be embarrassed. If you make a mistake, it means you're learning, all right? If you're not making a mistake, good for you, you know it. But if you're making a mistake, you're learning. So you should be happy that you're learning. We're all here to learn on this call, right? We're not just here because this is entertaining, even though that this is entertaining, okay? So let's dive right in. Before we dive, actually, I say dive right in, but before we dive in, I'm gonna show you something. Let me share my iPad. On the notes page, hopefully you've been writing all this down in your notes, in your pure notes. On this notes page, I want you to keep an area over here called related notes, okay? So these are all the notes we have so far. At the bottom, I want you to put an area for related notes, keep it blank, right? And then do the practice on another piece of paper, okay? So keep this area blank. Your pure notes should be devoid of any practice questions. Do your practice on another paper. All right, so let's start with this. So here's the question. Okay, so the first question I have is this angle here, x and y. So I want you to put all these answers will go in chat from now on, okay? So put these in chat. Is x equal to 2y? Question mark. Yes or no? Quickly. You can put it in private chat or public chat, either one. Is x equal to 2y? Okay, all right, so we already have some people making mistakes. Good, good, good. All right, so let's see. I'm not sure. Let's see, let's look at, so here. What does this look like? This reminds us of, let's see, this one, right? So we have this shape here, which is the same shape we have over here. So is x equal to 2y? Let's see, if I make this 20, so 20 is not equal to 30, right? It's not. Good. Okay, so if you made a mistake, That's amazing. You are learning, okay? That means take a look at this image and just commit this to memory. So what's the relationship? Actually, not yet. Let's ask another question. New question. C, x, right, and t, y. Is x equal to y? Question, yes or no? Put it in chat. Yes or no? No, all right, no, this would be no, right? Let's see, do we have a diagram for this one? I wonder. I don't think so. But what you can see from this diagram is that if I draw out something over here, right, like this, then what is the relationship between this and this? It's half, right? So this would be 69.87. So these two are not the same, all right? So look, if you're getting these wrong, that's amazing. It's really good if you're getting these wrong. So the first thing we learned from this shape here, where's the relationship of 2x? The 2x relationship is down here. It's only for an angle at the center and an angle at the circumference, right? At the circumference. This point over here, oops, on the right side, this point here is not at the circumference, okay? So the relationship between, now the relationship is 2x. So 2x equals y. Now this is true, but not outside, right? Good. And there is no relationship between a point here and a point outside the circle. There's no relationship between x and y here, okay? Good, good, good. One more, let's keep going. X, y. Question is x equal to y? Question mark. Let's put it yes or no. Yes or no, yes or no. Good, excellent. Yes, it is. And if you don't quite get this initially, then this is the radius r. This is the radius r. So you get an isosceles triangle, right? So because of isosceles, x is equal to y. So if this is new for you, you can come up here under related notes and write this down. If two sides of triangle are radius, then, ooh, I forgot how to write this down. Isosceles, maybe that's how you spell it? I don't know, isosceles, all right? Good. All right, so let's keep going, let's keep going. Let's go to the second question now, this one. Is this angle x and this angle O, all right, let's call this y, x equals y, question mark, yes or no? Quickly, quickly, in chat, yes or no, yes or no? So we have no's, no's, awesome, good, no's. Let's go back down to the shape that we looked at. Which shape is this? Oh, this one right here. If we move this down, this is the shape, right? X and Y. Next question, what is the relationship between this one and this one? Oh, X and Y. What's the relationship between these two? Can you put it in the chat? What's the relationship arithmetically, like in terms of X and Y? So again, let's visualize this here. So someone is saying X plus Y equals 180. Is that true? 130 plus 100 does not give us 180. Interesting. So someone said big brain moments. Let's do this big brain moment. Let's look at this one. Notice how, let's say 120 here. This up here is half of the center, right? And this down here is 180 minus this term, right? Okay, 120 is not a good example. Let's do 100. So this term up here is half. And so if this is x, this is 1/2 x. right? 1/2 times x. And this is 180, oops, 180 minus half x, right? So arithmetically, we can bring this relationship about, which is that x is equal to 180 minus y over 2. All right? Isn't that cool? Isn't that cool? A quick yes or no poll. Isn't that awesome? Yeah, cool. This is pretty awesome, right? So hopefully the visualization helps you do this, because to do this, you have to basically draw out this piece here, right? And then this, and you figure this out. Good. All right. So, all right, we're going to speed up. You should be getting these pretty well now. Next question. ABC, x. Is x equal to 90 degrees? Yes or no? Is x equal to 90 degrees? Some people say no, some people say yes. Good. Some people are making mistakes publicly. I love it. It's okay if you make mistakes. You're learning. The answer is no. Why is it no? Let's go back to our rule. This one, 90-degree rule. The 90-degree rule requires this line to go through the center, right? Only if the base of the diameter, then it's 90 degrees. This is not the diameter, right? Therefore, it's not 90 degrees. So good, you learned something new. Whoever made the mistake learned something new. Well done. Okay. Angle O, x, and B. Y, right? Same thing here. Same thing that we already did this one. You know the relationship between x and y, right? Good. All right, let's keep going. Number 4, we have a new shape here. ABD is this one, x, and BAD. Sorry, no, B, this one, y. X equal to y, question mark? X equal to y, question mark, yes or no? All right, guys, good. Everyone says no. That makes sense. Also, please be careful. So in chat, let's be kind and nice and polite to each other. All right, this is a public chat. What about x and y? Let's stay professional in chat. All right, is x equal to y? Question mark. Good, nice. Yes. All right. If you're struggling, if you don't know why, then if it doesn't make sense, you have this point here and this point here, right? And you're drawing 2 triangles from the same points, like this one. 2 triangles from the same point. So 50-50, right? So this is also x has to equal to y in this case, right? Good. Is this 90 degrees? X. So the question is x equal to 90 degrees? X equal to 90, question mark? Yes or no? Ooh, people are thinking on this one. People are taking time.
Is BD the diameter?
So actually, I'm not sure mathematically if this is 90. I've not done the math on this one, but just by looking at this shape, this is you cannot assume that this is 90.
Yes.
Looking at the shape, right? So be careful. Even if you see something like this, just be careful. Don't just assume it's 90. I'm not sure actually. Maybe if you do the math out, maybe this ends up being 90. I don't recall. Good. Okay. I think that's all the questions I had. Which angles? You can notice that x is equal to y here, right? Is x equal to y, question mark, yes or no? Yeah, good. If you don't know this one, then everyone go up again to your related notes. In 2, if you have this, then x is equal to y, all right? You can put this in related notes. If you're making mistakes as you're going through this, then write these down in your notes. Update your circle notes above, okay? The whole point of this activity is to get better and better with these rules. All right, we have another scary one here. If this is x, write down in chat, which other angle is equal to x? Write down in chat, which other angle is equal to x? In chat. Yeah, good, good, CBE. This angle here is also x, right? Same thing. 2 points on the circumference and a triangle being drawn to the circumference, same angle, right? Let's say y, x equal to y, question mark? No, good, you guys are getting it, good, because let's say this is the segment. In this segment, all of them are the same. This is a different segment now, right? That's why it's not gonna be the same. Good, okay. Let's remove this one. And let's put y. Put into chat, what is the relationship between x and y? Can you put into chat, what's the relationship between x and y? Good, y equals to 2x, right? You guys, you have the solutions right here. 100 is twice of 50. And notice this has to be in the center, right? This has to be in the center. If we go up to this one, where did it go? Yeah. So this is x, right? Question for you is 2x equal to y? Question mark. Is 2x equal to y? No, it's not, right? Good, because this is not the center. This is not the center, right? Therefore, you can't use that rule. That rule has to be used for the center. Good, good, good. You guys are getting this. You guys are getting much better. All right, let's speed it up then. What other question did I have? One second. Ah, there we go. Okay. Move this. X, y. No, sorry. X, y. What's the relationship between x and y here? This one's a thinker. The answer is not no, it's a relationship in equation. What's the relationship between x and y? Okay, so somebody says 2x equals y, right? And somebody says x, what is it? Equals to 180 minus y. And somebody says x plus y equals 180. Okay, good. People are learning. People are learning. There's a lot of mistakes in here. Oh, actually, never mind. So I didn't realize. So this and this is correct. Reason being is if this is a 90 degrees, right? You have to spot that because this is a tangent. This is also a tangent, and this here is it's a quadrilateral. So the angles inside the quadrilateral add up to 360, right? So somebody explained this very well. X plus 90 plus 90 plus y is equal to 360, right? Therefore, x plus y is equal to 360 minus 180, right? So therefore, x plus y is equal to 180, right? Good, 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 good. So if you thought that if you thought that x is equal to 2y, again, I go back to this. That's only true when one is at the center and one is at the circumference. It's not true for the point outside, okay? There is a relationship between, like we learned earlier, there is a relationship between x and y here. Again, x and y are related, but you can get there mathematically. I would not recommend memorizing that relationship. You can get there by understanding the math behind it. Good, all right, let's keep going. Actually, let me do a quick check-in. Is this helpful so far? Is this activity helpful? Before I keep going. Oh, nice, awesome, 100% of you, this is helpful. Good, that makes me very happy. Good, all right. And are you learning? Are you learning something? Awesome, good. If you're learning, that means you're making mistakes. So make mistakes, make it publicly, be proud. The more mistakes you make, the more you learn. Again, 100% of you. That makes me very, very happy. Excellent, excellent. Good. I think this was the only last one here. Yeah, we also know if this is x and this is y. Can you put that in chat again? What's the relationship? We've done this before, but let's put it in the chat. X plus y equals to 180. Actually, I guess we haven't done this before. That's using this diagram here. So if this is your segment, then this is one angle on one side of the circumference, on one side of the segment at the circumference. This is the other one, right? So x plus y is 180. Notice we saw this in this rule, right? So if you did not get this, then again, write this down in your notes. Okay. Trick question. This is a trick one. Be careful. X, y. Is this still true? Is x plus y equals to 180? Is this still true? Is x plus y still equal to 180? Yes or no? Ooh, people are thinking. All right, some bold people are saying yes. Yeah, good. All right, it's yes. I was tricking you because now you just draw the segment this way, right? The segment does not have to be from C to B. It can also be from here, right? This can also be a segment. So this and this are complementary. Good, good. You guys, that means you're understanding. You're not just memorizing. You're understanding that this time you're picking these 2 points to make the 2 separate segments. Good, 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 good. This makes me very happy. You guys are crushing it. All right. Okay. If this, we have this shape here. What is A plus B plus C plus D? Can you put it in the chat? Okay, someone says 360, someone says 180. So good, if you made a mistake publicly, that's amazing. And someone says 720, all right? So the answer is 360. It is a quadrilateral, right? A shape with 4 sides is always, the sum is always 360. It's inscribed in the circle, it's 360. So again, write this down in chat, sorry, in your notes. If you struggled, that quadrilateral angles add up to 360, right? And at the same time, we can write down triangle angles add up to 180, okay? Now this is used, I'm stressing this because this is used very, very frequently in these angle properties. For example, if we come in here, A, B, C, D, right? Again, this is a quadrilateral, a weird looking quadrilateral, but still quadrilateral. These add up to 360. This thing also adds up to 360, right? This thing also, again, angles add up to 360, all right? So start noticing that this shape has so many quadrilaterals inside of it, right? Same thing here. This thing also adds up to 360. So this can be used. Good, 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 good. All right, let's move to this one. Y, if this is Y, oops. X equal to Y, question mark. Put this in chat, X equal to Y, question mark. Yep, X is equal to Y, good, because 2 points here and then 2 angles at the circumference. Good, good, good. All right. This is X, this is Y. Now, is X equal to Y, question mark. Is X equal to Y? This one's tricky. So if we come up here to this rule here, where did it go? I thought I had a rule for this. There we go. So if we have these, yeah, well, actually, this X is not equal to Y. Don't learn this, right? Oh, that is true. Only if this line and this line are parallel. Well, not that one. If these 2 lines are parallel, then that is true. Correct. So actually, you can write this down. up here. 5. Oops. X, y. X equal to y if two lines are, wow, I'm running into my old notes. Parallel. Good, good, good. Okay, all right, so let's keep going. This is pretty simple. What can you tell me, what is the importance of this? If this line is going through the center, what can you tell me about this shape? Can you put in the chat? If that line is going through the center, what can you tell me about the shape? Somebody says, okay, 90 degrees. Yeah, tell me more. What is 90 degrees? Where? Yeah, good. This thing here is 90 degrees, right? So this is getting to the second piece, which is when you look at a new problem like this, it can be quite daunting. Break it down. Again, use this method of decomposition we learned yesterday, right? Decomposition. Right? So the first thing is you pick 2 points. So you know this is x, right? 2 triangles. Then you pick 2 more points. Let's pick this point and this point. So let's say this is y, then this is also y, right? Same thing. Then notice that this is going to the center. Oh, interesting, okay. Well, that means that this thing right here is a right angle triangle. So we know that this is right angle. Okay, good. What else can we see? We have a crossing thing here. So z is equal to z, w is equal to w, right? So you start getting all of these things. So in decomposition, don't be scared. Just work with small pieces that you understand. And it's okay to have all these variables on the screen. And I'll show you why. Let's skip this one. Let's come down here. Is this a right angle? Question mark. Yes or no? All right, somebody says no. Somebody says yes. Somebody says yes. Yeah, so this one's tricky. They're trying to trick you. This looks like a right angle because it's like meeting the tangent, but it's not, because if you do 180 minus 53 minus 39, you don't get 90, right? And notice this is also not going through the center. This has to go through the center. We don't know if this is going through the center. All right, so if you miss this, then just go back up to the rule that we wrote down in here, this one, and just know that it has to go through the center, okay, for that to be true. Good, I love how many mistakes we're making. We're learning a tremendous amount. Okay, let's come into here now. So take some time to figure out and tell me, what is this angle? What is angle D with respect to x? All right, so think about this one. What is D with respect to x? Good, okay, so D is equal to, so we'll leave this D up here. Write this down. D is equal to 3 over 2x. Okay, good. Let's say this is A and this is B. Is A equal to B? A equal to B, question mark? Yes or no? Somebody says yes, somebody says no. All right, so let's take a look at this. If we come down to this one, if I move this around, you'll notice my angle C and angle B are not the same, right? This would only be, yeah, well, actually this would really only be the same if you really wanted to make this the same, then this would have to be, if this line was true, okay? Good, all right, you guys are getting this. So A and B are not the same, all right? And good, okay, so it's just important. This is actually a big one. Don't remember that A and B are not the same. All right, whew, this is a tricky one. A lot is going on here. So take some time now and do this activity on your own. Figure out as much ever you can figure out by looking at this shape. All right, we've done a lot of practice now. See what you can figure out. So just on your piece of paper, just figure out whatever you can figure out in this. Isn't this crazy? They only give you one angle. They only give you one angle, and you're supposed to figure out a bunch of other stuff. That's pretty crazy, right? Okay, so let's keep thinking. Let's keep thinking. Again, break it down. Do decomposition. Work with what you know. Take 2 points on the center. Figure out what angles you know. Take 2 points on the circumference and figure out what you know. Take a look at the center. What is going through the center? Are there any 90 degrees? Are there any isosceles triangles? Okay, yeah, so you guys have probably done this, but the key I want to get this in, which is that this can be scary. When you first saw this, was this scary? Yes or no? I'm gonna do a poll. When you first saw this, was this scary? Yes or no? Okay, half-half. It was scary for some, it's not scary for the others. Yeah, so this can be scary. So let's learn to just do this decomposition piece. Let's take a pause and pick any 2 sides. So let's pick this and this. So we know that A and A are the same. All right, let's pick 2 more sides. This side, and we know that B and B are the same. Correct? Thanks for the tip on the different colors. Let's pick these 2 sides. All right, then we know that C and C are the same, right? You're starting to figure out so much, like so much you're figuring out. Let's keep going. 2 more sides. This and this. Oh, we've already done this, right? Have I already gone around the entire circle? Ah, no, not this. This and this. So this is 48. We know that this is 48. All right, good. All right, what else can we know? Well, this is 90. Why is this 90? Did you guys catch that? This is 90. This is 90 because of this beautiful rule up here. The perpendicular bisector of a chord. Perpendicular bisector of a chord. This is the chord, right? And this is a perpendicular bisector. Notice it's cutting it in half. So perpendicular bisector is at 90 degrees and goes to the center. So it's going through the center. Therefore, this has to be 90 degrees, right? Good, okay, so you caught this. What else do we know? We know that this is the radius, this is the radius, this is the radius, right? So therefore, B is equal to B, right? A is equal to A, right? So many things we know because this length and this length is the same. I'm gonna do a quick check. This was a little quick. Did that step make sense with the radius? Yes or no? Did that step make sense? Okay, good, good, right. Yeah, so you have isosceles triangles, right? So you start figuring out so much, like so much information you start figuring out. Then you also know that, let's say this is, I'm running out of letters. A, B, C.
Question.
D, D. Yeah.
Does that mean A is equal to 48 plus B?
A is equal to 48 plus B. All right, let's see why. And why do you say that?
Because EA is equal to EB and both of it meet at the same point D. So by right, AD and BD are equal.
Ah, okay, okay. So you're saying this triangle, right?
Yes.
Is that why?
Yes.
Yeah, good question. So this would only be true if this length and this length are the same. If these 2 lengths are not the same, then this is not true. So then this angle here and this angle here would not be the same. Good question. Good, awesome. I applaud you asking the question. Good, all right, so then this is no longer scary because we've broken it down into smaller and smaller pieces. Obviously, you won't have letters, like you'll be doing this with numbers, So if you were to start again, you would just break this down into, if this is 48, then you know this is 48. And then you like basically keep propagating this one number all over the map, all right? Good, all right, so we've done these, we know how to do this. What was my question in here? Okay. Let's actually skip this one for now. We know how to do this also. Let's come down here. Okay, so I want to show you guys one last thing on this piece, which is embracing uncertainty. So again, there's a lot of stuff going on in this. Just take a minute to look at this and see what you can figure out. So again, take this step by step. Just see whatever you can figure out. Okay, so there's two ways to do this. Let's do this together. There's two ways to do this. One is work with what you know. And then build from there. So for example, if we come in here, we know this angle, right? 110. So how can we build from this? Well, there's a shape over here. So we know that we know the relationship between these two, right? What's the relationship between these two? If this is x, then this is half x, and then 180 minus half x is equal to 110, right? So then you got this shape. That's another relationship that we know. Or if we start somewhere else, we know this is 62 between these 2 points. Therefore, this is also 62, right? How do we build from here? So then sometimes you get stuck. So if you get stuck, the second piece, which is how to go ahead from here, is 2, is assume something as x, and then build from there. So that's this piece that I did here, which is to figure out the relationship between x and 110, I had an equation, right? And so I use this equation, which is, which I put 180 minus half x is equal to 110, right? Is that correct? 180 minus half, yeah. 180 minus half is equal to 110, right? That's the equation we came up with. And what you'll see is from here, you can solve for x. So you can get x from here. So this becomes 70, x equals to 35, right? So now you know 35. Now you have new information, 35. Then you have another equation, x, right? So you do 360 minus 70 minus 2x is equal to what? No, is equal to 2. 360 minus 70 is equal to 2x. All right, so then you get that from there. But the point is, you keep assuming something as x, and then solve for it, right? So let's say, what is this equal to? 360, that is 290 divided by 2, 145. This does not make sense. Did I do my math wrong? This does not look to scale. But anyways, let's keep going. The point is not the math. The point is this method, right? Then you know this one. So etc. You just keep going, right? So the main point is, you work with what you know, or you assume something as x, and then you solve for x. Okay, and then you build from there. So the first part of this is that you understand the rules properly, which is all of this portion that we went up here. Okay. The second part is this algebra portion, which is pick something as x and solve for it. This one just needs practice. This one we can't really go through together, but there's a lot of practice problems that I have put on the website. So if you go back here, you will see there are practice questions and answers. So there's set 1, set 2, set 3. So you can practice this algebra portion. Okay. So that is all I had today for you all. For tomorrow, we're going to be doing, for Monday, there's no class this weekend. For Monday, we're going to be doing mensuration. So we're going to be using a lot of decomposition approach. Mensuration means finding out the area, volume, surface area, whatever, different shapes. And that one is really cool because I did mechanical engineering at Georgia Tech, and you'll be surprised, mechanical engineering uses that concept very frequently. So I'll be showing you some of my homework from Georgia Tech and showing you how mensuration was used there. Okay, so the application is actually very, very fascinating.